Let's now talk about marginal probability mass functions and density functions. Let's revisit this plot from earlier. If we took a view just from one axis, so maybe we went down here and we peered along this, and maybe we added all the buses that were delayed and all of the buses that were not delayed, and we add those together, we would get the following. Note the notation f subscript x of x. That's the marginal probability distribution of x. You basically sum over all values of y, and that's what we get. We get fx of x, the marginal probability distribution of x. If we look at this in table form, when we sum over all y's for each value of x, we get this bottom row. This bottom row then represents fx of x. In other words, it tells us what's the probability that the bus is delayed versus the bus is not delayed. Let's look through an example here. Let's revisit our data from earlier. I've added in a row at the bottom that represents the sum over all y's for each x value. I've also added a column over here that represents the sum over all x's for each value of y. The marginal probability distribution fx of x, that's the summation over each value of our joint probability mass function, but summing over all values of y. Fx of x is represented by this bottom row. For example, when x equals 1, fx of 1 would be 0.045, fx of 2 would be 0.032, and so on. We can do the same thing for continuous variables. This is known as a marginal probability distribution for continuous variables. Instead of summation, fx of x is found by integrating over all y, fxy, that's our joint density function. And essentially, the effect of the y variable is integrated out or is just combined together. So for our example, fx of x, we're going to integrate over all values of y, 120 to 240 of fxy, which is 1 over 240. And when you do that, you get 1/2. In other words, if you were to kind of slice fxy up and you're only to look at the effect of x, the domain for x is 8.5 to 10.5. And if this were our density function, then our fxy would have to be 1/2 because the width of this is 2, which is 10.5 minus 8.5, and so the height has to be 1/2. So fx of x is 1/2. You can do the same thing for fy of y. We're integrating over all values of x. The domain for x is 8.5 to 10.5, and this means that fyy is 1 over 120. It's a uniformly distributed variable. Hopefully this screencast gives you an introduction to joint and marginal probability distributions.